Good afternoon, everyone. I welcome you all to today's webinar on TechGig.com. Today's webinar topic is WCS performance, profiling techniques, and tuning considerations. We are delighted to have Pratap Narasimhan, Senior Manager Technology at Sapient Netro. Pratap has over 12 years of experience in design and implementation of large-scale technology solutions in energy, entertainment, and retail industries, with about 4 years of specialized focus in e-commerce. In his current role, Pratap is accountable for end-to-end performance and scalability of a multi-channel commerce platform for one of the largest retailers in North America. Gentlemen, this presentation will continue for next 45 minutes and we will take your questions after the presentation. You can ask your questions by typing in the chat pane available in webinar control panel. So without further delay, I invite Pratap to present this webinar. Over to you, Pratap.
All right. I assume everyone is able to hear me. Keshav, am I audible?
Yes, you are audible. Please continue. Thanks.
Okay. Just give me 5 seconds before we get started. Okay. Thank you. First of all, thank you guys for taking time out to attend this webinar. In this webinar, we'll talk about how to achieve high performance for an online retail store built on Websphere Commerce server. Now, before we jump into specifics on Websphere Commerce, tuning, and levers, I'd like to spend a few minutes in performance in general, like why is performance critical for the success of an online retail store? How does site performance impact shopping behavior? Secondly, how do we approach performance tuning in an e-commerce system? After we address these two for about 10 minutes, then we'll switch focus to core WCS or Websphere Commerce Server specific tuning levers, where we'll talk about various tuning levers at different tiers. And finally, in the last 15 minutes, we will cover how do we diagnose performance issues in Websphere Commerce, right? How do we understand the performance characteristics of a JVM running on Websphere Commerce? So I think before we get started, I think we should also try and define what do we mean by high performance, right? So if you look at today's context, right, large online stores, right? When I mean large online stores, the likes of Amazon, Target, or Walmart, right? They do more than roughly about 5 million, right, in online sales on a regular day, and in peak days, the sales could almost go 3 to 4 times, to 15 to 20 million, right, on holidays, events like Black Friday or Cyber Monday, etc. What this really translates is, the system should be able to, support up to 40,000 orders placed every hour, right? Not just that, but also, roughly anywhere between 1,500 to 2,000 page views every second, right? Yes, this means that every second in peak traffic, we have 1,500 to 2,000 people hitting any pages in your website. And at this load, right, at this high traffic, the page should render in 2 to 3 seconds. So this is high performance, right? A cool website should not even blink under these loads. So this is a problem statement that we will try in the next 1 hour. So moving on to the next slide, right? Just one moment. Okay, so let's start talking about why are we even talking about performance, right? So this is like a recent study conducted by Forrester for Akamai. Akamai is one of the leading content delivery networks, right, on how performance affects shopping behavior. If you look at it closely, right, as I was staring at this closely, a few things came out very, very evident. Number one is, right, benchmarks for acceptable performance, right, has really shifted. Like, 4 or 5 years back, when a website, renders a page in 4 to 5 seconds, it was considered acceptable performance, right? Now that number has shifted to, 2 seconds. Your consumer expectations has shifted like to, to 2 seconds. The second thing that hits me is like this market is extremely competitive, right? Even a slight differentiation in performance can cause a big impact in revenues. And finally, it's just not just revenues, right? The impact is also on brand perception, your customer loyalty, goodwill, and if your site is down, you get even negative press, right? So a lot of things are riding, on performance, and it's not uncommon for sites to even sacrifice on functionality for the sake of performance, right? So you look at this particular graph. It says 79% of shoppers who are dissatisfied with the website are less likely to buy from the same site again. Now, if you couple this with the fact that this is such a competitive market, you would really lose out a lot of money if you don't build a site which can scale up and scale well with high performance. So net, right? Performance is extremely critical, for the success of any e-commerce website. So now that we understand why site performance, why is it critical? What are its implications, right? Let us spend a minute in understanding what does an e-commerce solution really entail, right? What does like a landscape look like? So look at this landscape, right? This is like a typical system context diagram for a stores application. When it's say, the central piece that you see store site is actually a consumer-facing e-commerce site. Like, look at the number of integration points, that this site integrates with, right? Either asynchronously or synchronously through various integration patterns, protocols. It doesn't matter if you built your site using Websphere Commerce or ATG or, hybrid, right? But one thing that is clear is, though the store site is just your, core piece of your ecosystem, it integrates with so many other systems, right? External systems, like things like, business tools for content refresh. You have CMS because the content needs to refresh every day. Your order is captured, it needs to be fulfilled, so you have an order management system. You have a lot of SaaS providers these days. You have payment plugins, you have SEO, you have analytics. The list like really goes on, right? So performance tuning in an e-commerce context is a massive undertaking, and it is just not restricted to your stores alone. To give you an example, right, if you look at any of these enterprise web services, if they go down and if you do not have right connection timeout or read timeout set, they can, hold your website at ransom and pretty much bring your cluster down, right? So you need to test every integration pattern, tune their configurations so that, you isolate your store site from any fluctuations in their performance, right? So in net, right, we are talking about a massive undertaking. Just to give you an example, right, in one of the solutions that I work on, we are like a 20-member team, trying to tune performance of a retail site for almost 1.5 years now, and we are not there completely yet, right? So in the interest of time, right, so this is a massive topic, and you can talk about days about performance in e-commerce, but I'm going to restrict myself to a 101, which will give you a good jump start on what are the key levers that you look at, right? So now that we looked at the landscape, let's look at how do you approach performance tuning. So let's say you get into a project and you're handed over the responsibility to start to manage or to run or drive the performance tuning, right? How do you approach it, even for the store site, right? So we look at a typical browser request, right? If you go to Amazon.com or Target.com or any of these websites, the typical browser request travels through multiple network hops, right? You type www.xyz.com, it is typically intercepted by a CDN or a content delivery network like Akamai. From there, it goes to a load balancer. You have multiple traffic managers, and then it comes to the web server, and then it goes to the JVM node, and then it goes to the database or any third-party services, right? So each tier here will require focused performance tuning, and the focused performance tuning is not a one-time activity. It needs to be done iteratively. It needs to be, for each of these configurations in these tier, right? No one size fits all, right? Every site is unique in its own way, and these configurations, etc., will need to be arrived only by, repeated performance tests. So, net, right, tuning is a very iterative process, right? When you talk about tuning like thread count or connection pool, timeout configurations, these are all established after repetitive tests. The second is, if you look at this, one thing will be evident, right? It's not just the code or the design that requires tuning. There are several factors beyond your code that can impact performance, right? To give you one example, right? A simple disk I/O read change in your storage layer can just cause a massive improvement in your site-wide performance, right? On the flip side, if you mess up the I/O read, and your performance can pretty much be killed across the site. So it's both ways, right? Every layer you see here, load balancer, web server, JVM, databases, front-end browser, every layer will require performance tuning and is sensitive, right? So with this background, right, let's now switch focus to WCS, or Websphere Commerce Server. So far, we spent a quick few minutes understanding why is performance important, what are the implications, and we also talked about how do we approach performance in a tiered fashion, right? How do we approach tuning in a tiered fashion? Now, before we start talking about the various tiers of Websphere Commerce and the tuning levers, right, let's spend a few minutes understanding the application architecture of Websphere Commerce. So Websphere Commerce is, right, a very popular e-commerce package, right? A lot of e-commerce sites are built on that, like ATG. At the end of the day, it's just ultimately another Java application or a J2E application running on the Websphere application container, right? Commerce offers a lot of out-of-the-box features, and every store that implements Websphere will also have to do a lot of customization to meet its specific requirements, right? So for example, right, to support this customization, Websphere is also very layered. So when a request comes into your application server running Websphere Commerce Server, it goes through a servlet filter chain, and from there it is sent to the presentation layer, which is a structs-driven MVC framework. Then the controller command, there's a controller command for the action that you requested. That opens up a transactional context. It opens one or more task commands, which are smaller units of command, and then each task command will access the database to access beans and entity beans. It's a very layered architecture, right? So every layer needs to be understood very well before we start, looking at tuning, right? So if I look at the tiers, or what are the performance sensitive tiers that affect your performance. So you have front-end optimizations, right? This is like your browser. This actually has nothing to do with Websphere Commerce, right? Doesn't matter whether you are running a J2E or .NET application. This is common for everyone. Then we have web server tuning. Then we have Dyna-Cache. How do you size? How do you tune it? And then we have JVM tuning, and then you have the WAS, or the Websphere Application Server tuning. And then finally, we have the Websphere Framework tuning and the database tier tuning. So the next, 20 minutes, right, I'm going to talk about each of these, tiers one by one. A key thing to note is, right, this will just be a 101, right? Each of these tiers can be actually talked about it for days together, and you're going to write even a book on it. So this is intended just to get you a good jump start. So let's keep moving and talk about the first tier, front-end optimizations. So in one of the reports that I was reviewing, I read that if your page responds is, say, 3 seconds, right, your page has to come back in 3 seconds, only 20% of the time can be afforded to spend in your server tier or in your core Websphere Commerce Server, engine, right? Your remaining 80% of your end-user response time, or 2.4 seconds of the 3 seconds, is typically spent on your browser in rendering the page, right? A page will contain a lot of JavaScripts, CSS files, images, right? All these will have to be downloaded. The browser has an inherent cost of rendering. There's also an aspect of which browser you're using, right? If you're using browsers like IE7, IE6, you are in for a larger trouble because they're not really modern browsers. But if you're looking Chrome or Firefox, they do a much better job. So if you look at, if you look at the gist of it, right, you could just tune your Websphere Commerce server application, in an excellent fashion, and your site can still run like a dog. It can be extremely slow. So this is a very important tier that we need to look at. So key suggestions, right, to speed up your page, obvious ones, right, lesser number of HTTP requests. 75 to, is a good number of HTTP requests. If your HTTP request crosses 100, 120, you are in for trouble. Similarly, page weight. Your page weight should be like 750 KB or less. It cannot be like 1.5 MB. The third is image footprint, right? How many images do you have? Simple things, right? Like, I've seen sites which are with a large hero image, and if you right-click properties on it, it will say it's like 240 KB. If you remove the transparency and save it as a GIF, it will come down to like 20 KB, right? So this is like a simple change, but a very, very, will have a significant impact on the page. Other simple stuff, make sure your static assets are all compressed so that, when they go across the wire, they are less than bytes. Make sure they are minified. Minification is just a process of stripping out all spaces, white spaces, etc. in your JavaScript, CSS. And consider implementing domain sharding, right? Every browser, right, I'm talking about a modern browser, can typically make 4 to 5 connections per DNS. So if you want domain sharding, then spread across your content across multiple domains, so that the browser will actually be able to download them from simultaneously from multiple domains, right? Like you can do 10, 15 connections. The last is a very obvious one. If your page is very, very heavy, you should lazy load, right? When I say lazy load them behind the scenes, or load them only when the user scrolls down, right? All these changes, right, will have a significant impact because you're addressing 80% of your end user response time, right? So that's like a quick view of, what are some of the obvious front-end optimizations that you can do. Another thing to add is there are various tools, freewares like Firebug, Dyna-Cache, PageSpeed, Wiselo. All these are tools which will give you an excellent view on how are you performing against these metrics and for you to continue tuning. So with this, right, I move over to the next tier or the next performance tier, which is the web server optimizations, right? So, the common web server that we use for any WebSphere application is the IBM HTTP server, right? It's a simple HTTP server. It's mostly a proxy just to route your incoming requests to your JVM or to render, JavaScript, CSS that are actually stored on your web server. So very simple functionality, right? But still, there is a lot of tuning that you can do in IHS. So, the way IHS works is, right, one instance of IHS is a single parent process, and that will spawn multiple child processes, right? So the first thing that you'll need to answer is, right, how many simultaneous connections does the server need to support? To give you a quick math, let's say that your e-commerce site will have to do about 1,500 requests per second. Now, 1,500 requests per second, typically if you have Akamai fronting your site, you could save easily up to like, another 500. So that will bring down to 1,000 requests per second. And if you have, say, 10 web servers, and that will kind of translate to 100 requests per second in each of these web servers. So you need to arrive at a number through a mathematical model and then tune iteratively based on how your CPU is, how your memory consumption, etc. A lot of configuration parameters are available in the web server, like server limit, how many child processes can you spawn, what is the maximum number of threads you can spawn, what is the maximum number of clients can it take, and there's this concept of min and max there, where if you cross the threshold, how many can you really go before the before the process comes down, crashing, right? So web server very straightforward in terms of configurations, but can have a huge impact. So very less number of configurations, but needs to be carefully, aligned and reviewed. So we covered about front-end optimizations, and we talked about web server optimization. So let's now, move on to the next one, Dyna-Cache. So before we talk about Dyna-Cache, right, let's talk about caching in general. The truth is, right, in today's context, right, given the high traffic that these e-commerce sites withstand, they simply cannot scale without caching, right? When you talk about every second, 1,000 to 1,500 requests coming in, it's impossible for routing every request to your application server, read the database, render it, and yet come back in 2 seconds. It's just not possible. So caching is a significant, important ammunition to achieve high performance. So it's not an optional decision, right? It's a mandatory decision, right? The thumb rule is cache the page contents as closest to the user, right? You have a lot of content delivery, or CDNs, right, these days, which will cache content, close to the end user browser, right? So you could have edge servers, EDG edge servers in multiple locations, Boston, Minneapolis, or California. If your site is doing multiple countries, it can have it in multiple locations inside those countries, right? So that when a content is cached there, it won't even bother your web server or your app server in rendering, right? The page is rendered directly from that, right? So it's a very powerful technique. So we will talk about edge side caching in a bit, but the other caching that Websphere offers is Dyna-Cache, right? Dyna-Cache is the in-memory cache service in Websphere application server, right? It basically stores a dictionary of objects, like a key value mapping, right? Think of it as just a hash table. So it resides in the JVM, right? It has a lot of disk offload capabilities. So, it is given if it exceeds the memory threshold, because it's going to sit in your heap, right? So if your heap is 1.5 GB, you need to keep some, 300, 400 MB for Dyna-Cache, right? So it's going to sit in your heap. But it has disk offload capabilities, and it also has eviction techniques, right? Let's say you cached a particular page or a fragment, and if it is not really used, it will kick, it uses the least resident used algorithm to, kick out those entries. So if you look at Dyna-Cache, it supports 3 types of caching. So one is called the full page caching. So if you look at a lot of websites, like they have home pages, they have category pages, right? Like you can click on electronics or baby or women, men, right? They have categories, right? These pages, and then you have these, even the product detail page. Let's say I search for iPhone, a page which talks about entirely iPhone, right? Kind of shows up. These pages, right? They don't differ from user to user, right? They have a few dynamic components, but they're largely static. So you should cache all these pages in Dyna-Cache. So, and if you cache here, you can also offload the content to edge solutions like Akamai, right? The next is your JSP fragment caching, right? Every JSP is made up of multiple fragments, right? So this is the most commonly used caching techniques. So an example is a good example is like a header and a footer. Let's say you use your header in all the pages, right? And a header has a lot of processing logic because it has to list all the categories, etc. But if you just cache them in Dyna-Cache, from when it goes from page to page, it doesn't need to reconstruct itself. So it's a very it saves the page response time significantly. And the last is the command caching, right? We talked about some time back that Websphere Commerce has controller commands, task commands, etc. Right? So if you want to read attributes of a product, like let's say price or reviews or promotion details, etc. Right? They're all retrieved through a task command. And if you cache these task commands, right, the next time when you actually invoke these commands from a fragment or from a controller command, right, it won't actually go and make a call to the database. It will render itself from the Dyna-Cache. So all Dyna-Cache is very important. The key side note to also note is that as you cache a lot of these pages, you also need to come up with an invalidation strategy. Let's say you cached price. What if the business goes and changes the price from X to Y? You can't display the older price on the site. So you need some invalidation strategies also built in. So, talked about Dyna-Cache, how important is it? Continuing on it, right? The other technique that is very, very popular is warming up your cache or pre-warm up. Let's say tomorrow is a holiday, right? And you expect very high traffic hitting your site. You could just warm up the price task commands for all the prices in your catalog, ahead of time, so that when these pages get loaded, right, when these pages get hit, your traffic on your database or your JVM is much lesser than it would otherwise. You could also cache pages like your product detail page, quick view, etc. Right, home page, category page. So warming up of cache is very, very efficient. Now we come to another topic called in-memory grids, right? Dyna-Cache is very good, but the challenge you will have is it resides on your local JVM, right? So let's say you have 100 or 200 JVMs, supporting your site. If I want to ensure a home page is cached, it needs to be, cached in all the 100 JVMs before you can be confident that it's completely cached, right? So, that's why we use, in-memory grids like, for distributed caching, right? Websphere Extreme Scale is a product which is an in-memory grid. It supports distributed caching, offers extremely high scalability, transactional support, and WCS can actually talk to Websphere Extreme Scale through RMI or ORB calls. So now let's talk about WXS or Extreme Scale for a little bit. Now let's say you cached a lot of content in your Dyna-Cache. Now your heap is going to grow. So if you configure your Dyna-Cache provider as an external in-memory grid, then this grid is going to be shared across all JVMs. It will easily save 300 to 400 MB in each of these JVMs. The other advantage you have is you cache it once, you can be rest assured that all JVMs read from it, right? And so it's very powerful. It's a separate product. It supports a lot of other features, but it also has replication. So if you have, let's say you have 2 data centers, right, for either disaster recovery or even in an active mode, you need to make sure cache is replicated efficiently between the 2 data centers. So you will have a Websphere Extreme Scale installation in one and data center in the second one, right? And it offers replication services. So consider using in-memory grid, shared in-memory grid, if you want to cache a lot of content. I remember that we managed to cache up to about easy up to 20 GB worth of content, in extreme scale. Something that you can't do when you have, it's going to be, you can do, but it's going to be much tricky when you just use your Dyna-Cache, sitting on your heap. Finally, right, when it comes to caching, use of a content delivery network is extremely important. In peak seasons, right, I have seen sites which will offload up to 60% of their total page views at just Akamai or any of these content delivery networks. So let's say there are 100,000 people hitting your website, and you have a lot of pages that are fairly static with some dynamic components in it. You could just cache all of them at Akamai, so that only 400 or 1,000 makes their way into your your application server. So to summarize, right, caching is extremely important. You should definitely cache your pages closer to the user in Edge. And the third is, right, consider using like in-memory grids, if you want to achieve higher scalability and performance. So moving on from caching, I'm moving to the next layer, which is what are the tuning levers in WebSphere application server. Like I said, right, WCS is just another Java application running on VAS. So having the application container properly optimized will just improve your performance. So a few things are very important, right? First is your web container, right? Every request coming in from the web server to your JVM is assigned a thread from the web container thread pool, right? So, there used to be a belief that, set this web container thread pool to a very high number of threads because it would improve throughput and the ability to handle a lot of concurrent users. That's simply not true, right? Because if you have too many web container threads, each CPU, would be dealing with a large number of requests. There will be context switching, etc., than actually doing the job, right? So we need to arrive at the min and max of web container threads in a very iterative fashion, right? It depends on a lot of factors. How many CPUs do you have in your, in your bots? How many are they dual core, quad core, are they single core, right? I mean, do they even have hyper-threading? A lot of these would also, play a role, right? In the past we have set the values around 25 to 30 containers, 25 to 30 threads as a limit per JVM, and this has worked out well. Setting it to something like 60, 70 and all will just make your CPU run very, very hard and will not give you the value. You will just see so much queuing. So, I would say start off with 5 threads per processor, right? 5 threads per, if you have 8 CPUs, right? Start off with 40, but assuming you have 2 JVMs, it will be 20 each, and then keep iteratively tuning to arrive at that sweet spot, right? It's a balancing act. So web container, we talked about web container, most important thread pool because that's the one that is actually doing your job. The next one is your Websphere, WCS ORB connection pool. Important only if you're doing a lot of remote requests using RMI. Default values like 50/50, I believe. You can set it to anything higher just based on how you communicate to your how much requests do you need through an RMI call. Just make sure this doesn't become a bottleneck, because if this becomes a bottleneck and you won't even realize, you will think that your thread is slow, but it's actually getting all accumulated here. So unlike the next one is the database connection pool, right? Your JDBC connection pool. Unlike the web container thread pool, right, where it needs to be a very iterative activity, this one is something that you can actually calculate, right? It needs to be a minimum of, it needs to be at a bare minimal equal to your web container pool. So if you have 25 threads or 30 threads, then set your database connection pool to min of 30. The other advantage we have seen is, right, keep the min and max active. The way it works is, right, when your server starts, your connections are not warmed up. When your server starts, the connections are not warmed up. But as they get used, your connections are warmed up. But if you set the min value to low, it will again get cleaned up. So it will not just go below the min values, but setting the min value to be the same of max value and make sure that your connections always remain, so that all your subsequent requests will not have to undergo that extra connection cost, right? The other couple of other things that we have valued a lot is warm up your JDBC connection pools, right? As you start your server, JVMs, just warm the connection pools, right? Don't let for them to actually, lazily accumulate, right? That improves performance. The other big, performance gain that you can get, especially in Oracle rack architecture, is, let's say you have a 6-node Oracle, rack. Rack is a, real application cluster, 6 separate Oracle database servers, right? Divide your JVMs and hard bind them to each of their nodes, right? That will make sure that all threads on all JDBC connections from your JVM will talk to a particular node, right? It will not, disturb the other nodes. Otherwise, right, there's a lot of cost in the database spent on context switching from node to node. So introducing that DB node affinity has clearly, helped performance. So the next one is, so we talked of, continuing on web, application, tier or app container tuning, right? The next one is like prepare statement cache. A lot of people know that, right? When you have a JDBC connections, you can cache a lot of JDBC statements so that they're all precompiled and they don't need to be compiled again, right? there's no magic formula to arrive at the size. But the good approach is the first thing I would suggest is profile the SQL trace. When you load the page, see how many SQLs are being fired, and just make sure your cache is enough large above that, right? The other aspect I forgot to talk about is, right, Websphere has a very good, PMI or performance monitoring infrastructure. So if you go to the WAF admin console, you can configure a lot of these metrics, and when you do a load test, it will give you a real-time, metric view into, how is the cache, prepared statement cache being used, how many web container threads are used, how many are idle, are you spending a lot of time in, JDBC connections, acquiring all this, you'll get that view, right? And then finally, your JVM, right? We talked about what you can do with Websphere application server. Then coming to the underlying JVM, right? The main thing in a JVM is the heap size. I mean, heap size, will hit your garbage collection behavior. We have seen that your heap value of roughly anywhere between 1 and 1.5 is good. Your heap might be slightly, you need to make sure your heap accounts for Dyna-Cache if you're not using an external in-memory grid, right? So otherwise 1.5 GB is pretty good. The only trick is, let's say you're running a 32-bit JVM, right? You have 2 power 32 or 4 GB of space for the process, right? You divide the 4 GB into 1.5 GB for the heap, and then the remaining 2.5 GB for your native memory, right? If you set the heap higher than 1 and say go to 2, the only problem we've seen is, right, when garbage collections doesn't kick off for a long time, and when it kicks off, right, it tries to collect a lot of memory, a lot of objects, so you will see GC pauses, right? GC pause is extremely nasty because when the pause happens, your CPU just falls down to 0, right? And you really can't do anything. So just so make sure that your heap size is a balance between how frequent garbage collection runs, and at the same time ensure that there is no GC pause, right? The preferred garbage collection policy, for Websphere Commerce, my recommendation is GenCon, because GenCon creates separate areas, right? Like a nursery area for all your short-lived objects, and then your tenured area for your long-living objects. So in the heap, you could probably say somewhere between 350 to 400 MB can be kept for nursery, and the remaining for the tenured area. So that kind of concludes the Websphere application server level tuning. So moving on quickly to core framework tuning, right? Websphere Commerce server. I'm going to skim, breeze through some of this. You'll need to have Websphere Commerce specific knowledge to appreciate of some of these aspects. So the first one is, right, every controller command, right, has a feature called isGeneric. What it really does is, Websphere Commerce has 3 types of users, right? Anonymous users, guest and registered users. So commands that are not very user specific, right? You should mark the isGeneric flag as false. The advantage you have is, right, it will not flood your context tables. So Websphere maintains context and activities in the database. So if you make even anonymous commands that have no user context also start logging in that, it will flood your database and it will start showing database issues. So that's one thing. The second is, make sure, don't blindly use access beans and data beans, right? Because, sometimes they're not efficient. A simple JDBC helper when you're reading from multiple tables, if you use some of these data beans, right, they'll be very, very chatty, making multiple calls back and forth from the database, retrieving a lot more attributes than you really need, and kind of, it'll definitely stress your database. So use simple, custom JDBC queries, when you want to access data from related database. The third thing is, this is an important aspect, right? In the system context diagram and the earlier slides, we talked about Websphere Commerce having a lot of integration points, right? 50, almost like, at least 50 integration points, right? You could have up to so many. So, these integrations, right, we need to be very, very carefully reviewed, right? Always prefer asynchronous integration over synchronous integration, because it kind of isolates your application from any response time fluctuations on the service that you're accessing. The service won't hold your application at ransom, right? The second, but having said that, right, you cannot always, do asynchronous, right? Things like emails, etc., can be asynchronous, but when you're doing address verification or computing taxes, etc., it needs to be synchronous because the user is waiting, right? The key suggestion I would give is make sure that every integration point has a separate connection and a read timeout. So let's say that you're connecting to an address verification service, and that service is down or not responding properly, right? If you do not specify a connection timeout, your JVM or your web container will just wait indefinitely to establish a connection, right? And a lot of threads will start queuing in your JVM, and then that will start affecting every other JVMs. And in a few minutes, or in probably 15-20 minutes, your entire application will be down and your cluster will be down. So we need to be sure that we have connection timeouts, read timeouts specifically captured. The last thing is, right, access and data beans. I told you earlier that access beans are used to call the underlying entity beans. The simple reason is it has access control policies. Data beans are used primarily by JSPs, not from the controller or the task commands. Couple of other suggestions on Websphere Commerce specific. Websphere has another concept of registries, right? What registries are nothing but it caches a lot of runtime, data that are very static. They don't change, like static text, country, state, jurisdiction, etc. Right? So leverage registries and make registries in Dyna-Cache is very complementary in option. So leverage them. The last thing I want to talk about is bot calls, right? Bot calls are expensive. So when you're using, let's say you go to a page like you search for an iPhone page, right? It's a product detail page. It has a lot of information in it, right? Price, inventory, color, size, information, ratings, reviews, warranties, etc. Right? Each of these are attributes. So when you use a service like bot, right, it actually reads the entire data. One product can have 340, 350 attributes instead of just lazy loading them as you require. So we have seen, some of the pages take up to 20 seconds when we use bot, just came down to like 3 seconds after we kind of replace them with simple JDBC queries. Finally, a promotion engine, right? Websphere has a very sophisticated promotion engine. It's a very sophisticated one, but the challenge is it uses a club in your underlying data store to store the promotion data. Clubs are very, very expensive, and if you have a lot of promotions in your site, don't use clubs because it will always do an insert and then an update, and it can bring your database to its knees under high load. So I'm moving on to the database tier tuning considerations, right? Here, database, as you guys know, right, it's a single point of failure, right? You can have every layer scale very, very well, but ultimately everything relies on a database instance. So again, you could write a book on it, but key things that have helped us, like I said, consider using reverse key indexes when you have table columns, right, with very high block contentions. Implement node affinity. We talked about it earlier, and warm up your JDBC connection pools, right? The way to approach database tuning is Oracle especially has AWR reports, application workload report, and application session history reports, right? Run a load test and review the AWR and application session history very, very carefully to give you a good insight into what are the key wait events, what are the worst performing SQLs, are there blocks, how are the indexes, is there an underlying I/O problem, memory problem? It's a one-stop shop, right? Once you get the AWR, then you start applying some of these table and application designs to tune your, tune the database, right? The next one is a very often understated one, but a huge impact. Archive your tables. When you're, in Websphere, you have 700 tables, and some of the tables are very hot, meaning they have a very high transaction rate, context data, user data, order tables, payment instructions. They grow to enormous space, right? Payment instructions and all can quickly reach 100, 150 million. So archive them or purge them, periodically. It's not a production support operational job, right? It's a performance. It's very, very performance insensitive. So we typically archive orders beyond 20 million, right? So that your table has a sizable amount, and your read and write queries doesn't become slow, right? So we have, so if you look at it, right, we talked about a lot, right? We talked about front-end optimizations. We talked about web server tuning. We talked about your JVM tuning. We talked about WebSphere application tuning, container threads. How do we tune them? And then we also talked about database tuning, right? So so far, right, we have covered why is performance important, how do we approach performance tuning, and what are the various tiers that are performance sensitive, what are the key levers, right? Again, right, if you look at each of these tiers, whatever I've stated so far, right, should give you a jump start, right? Read about it. There's a lot available, out there in the info center and in other books to get you to dig deeper. So in the remainder of the session, right, which is, let us focus on how do you profile the performance characteristics. Okay, you've tuned it well, etc. Right? Now, when a JVM is slow, or if you're running out of memory, right, or if your CPU is very, very hot and you don't know what's the problem, right? How do you determine the root cause? What are the tools, data, logs available, right? So that's what we'll focus. So, four profiling techniques are that we've used extensively. One is your code profiling, right? That is not even part of performance testing or tuning, right? Every time a developer writes a code before he checks in, it's a good habit to profile the code and see how whether there are bottlenecks. The second aspect that will help us is thread dump analysis to see if a JVM is particularly slow. How do what are the issues? The third is heap dump. Heap, if there are any memory bottlenecks, etc. And the last is GP, again on memory, right? So let's start off with code profiling tools. A lot of you would be familiar with code profiling, right? You have profilers like JProfiler, Vantage Analyzer, Dyna-Cache, RAD, etc. Right? So profilers at the end of the day, they'll just, they have an agent service that will just plug, latch itself to your JVM and start recording or instrumenting every call, right? It gives you a nice tree-level view, using which you can find out, if I go to a page, say home page of a website, right, and the backend I switch on the profiler, I'll exactly know what are all the methods that are fired, right? So it'll help you identify specific performance issues, right? So it'll also help you identify a lot of inefficiencies, right? If you have an infinite loop, right, or if you're initializing objects again and again, all those things will be caught in profiling, right? So the key tactics would include your core Java code profiling, then second the SQL tracing, and then the last is something specific to WebSphere, right, which is Dyna-Cache functionality. So if you moving to the next slide, right, when you look at a profiler, it gives you a call tree. It gives you all the cost breakdown, right? What is the CPU for every method? What is the memory for every method? What is the cost of each of the method as a percentage of the total cost, right? It'll help you identify what are all the CPU dogs, right? Are there I/O bottlenecks? Everything will be, what is the memory footprint? How many SQL calls are you firing? In some of the pages, we have noticed that we initially used to see like 100, 150 SQL calls, and that's where caching helps, right? So if when I load a page like a product detail page, right, and I see that 150 calls are used, that's where I can figure out and see, okay, I can cache price, I can cache promotions, I can cache some of the attributes like description attributes, etc. So once you cache it, your SQL calls will drastically come down, right? So we benefited a lot by just doing code profiling. It will help you identify a lot of these bottlenecks, right? So a lot of So look at this screen, right? So it's one of the tools, Vantage Analyzer. It just tells you, a tree view, right, of all the costs, right? It also tells you, of the 100% cost, right? How many was spent in your tier? How many was spent on the database side? How many was spent in communication, right? What is the network cost? And then it gives you a drill down view of what are your most expensive JSPs, and you can drill down further and find out why is the JSP expensive. Is it because it's making a lot of database calls? It gives you that tree view, and it also gives you this view, right? You have multiple views, right? You can explore them, which will tell you what is the minimum time for this JSP to run, what's the maximum time, what's the average time. It's extremely useful, right? So one thing I mentioned is there are a lot of tools in the market, right? You need to make sure you have the right tool, obviously by looking at cost, but also looking at, a lot of these tools cost overhead on your JVM, right? So if a page comes back in, let's say 3 seconds, if you plug in your profiler, it might take 30 seconds, which is neither what we want, right? Because you will not be able to distinguish if your page is inherently slow or is it just because the profiler is causing an overhead. So we need to make sure you have visibility into that. Profilers should give you a lot of graphical view. It should help you fine tune. And one of the most important aspects is that you should be able to, there are a lot of profilers that can actually run on production environment as well, right? So if today, you come to work and someone says, yesterday the site was slow between 3 and 4 p.m., you should be able to go back in time and look at the profiler output for those time and find out what went wrong, right? So I've listed a lot of tools here: RAD, JProfiler, Vantage, Dyna-Trace. Explore them. They have their own pros and cons. So moving on from code profiling, right? Let's talk about memory profiling. So the memory is WCS creates a lot of objects, right? And we probably would realize that when we talk about Heap, etc., right? And memory utilization, right, can impact system performance significantly, right? So if you look at in theory, right? In theory, you should never run out of memory because garbage collection, runs periodically. But then what happens is, like, GC, garbage collection, only cleans up unused objects that are not referenced anymore, right? So therefore, if you have an object that is not used but is still referenced, then GC doesn't remove it, it will still be in the memory, right? So it will start causing leaks, etc., right? So when you look at memory problems itself, right, there are multiple types of issues. One is your high heap. Let's say you give a heap of 1.5 GB. If you're always there will be garbage collections periodically, right? But even after garbage collection happens, if your free space doesn't come down significantly, let's say by at least it comes down only by 10, 20 MB, right? You have a problem straight away. You are running very high on heap, and heap issues, right, will gradually slow down performance and eventually bring down your JVM. So that's one of the issues. The second is memory leaks. Right, like I just mentioned, right? If you have an object that is being referenced and it will not be released at all, so it will cause memory leaks. The third is, right, which is not very often seen but still very relevant, is native memory exhaustion. I talked about in a 4 GB process space, if 1.5 GB is allocated to your heap, your remaining 2.5 is for your native memory. So that process space could also run out of memory. So you need to watch out on that. And the last is heap fragmentation, right? So, when memory is released by garbage collection, if you don't have enough contiguous blocks of memory available, you will have an allocation failure. So fragmentation is also an issue. So how do we profile memory, right? So two key tools. One is heap dump. The other is your garbage collection logs, right? So if you look at heap dump, right? So heap dump is, like most of you know, right? You take a heap dump, it will give you a complete view of all the objects in the heap, right? It gives you, what are the top consumers, or what are the key objects, what is the size they occupy. It also gives you who are all the other objects that reference them, right? The good thing about heap dump here is, right, a garbage collection is forced before a dump. Now, if you have a heap of 1.4, you take a dump. right? It will force a GC just before taking a dump because it will clean all objects so that your heap dump only has objects for your interest, right? Objects that are still referenced and somehow not cleaned by garbage collection, right? So heap dumps used to be your classic text view. The problem with heap dump being that is, if you're running a 1.5 GB heap and you take a heap dump, the size of the file will be 1.4, 1.3 GB, right? To copy it to your tool in your Windows machine, right, it's going to be very, very tricky. So that's why we have portable heap dumps, right? Portable heap dumps is a compact heap dump, right? So when your heap is 1.2 GB, when you take a PhD or a portable heap dump, it will still be about 200, 300 MB. So you can easily copy it over to your local box and use tools like ISA Heap Analyzer to analyze them, right? So if you look at ISA, right, once you load a PhD heap dump, it gives you information in it will help you identify memory if there are any memory leaks. It will help you identify what are your key contributors to heap. So one example is, right, when we used to take heap dumps earlier, we used to always run into that cache objects are very, occupy like 300, 400, 500 MB in heap, right? Something that you don't want. So that's why an in-memory grid or a centralized or an external grid is helpful, because that heap size is completely removed from being used. So if you take, heap dumps are taken typically during load tests, etc. When the application is very hot, running very high heat, take a good heap dump and look at what are the objects, right? You should be able to tell you, and what are all the objects that are very highly used and not getting released properly. So the next one is talking about from heap dump is garbage collection, right? GC, like I was telling that the garbage collection policy that we typically use is GenCon, which has a tenured area, and it has separate garbage collection cycles for nursery and tenured areas, right? So if nursery is 350 MB, it will keep collecting it very often so that your short-lived objects are being flushed out very, very frequently, and then only your tenured, your major collection or your tenured area collection is less frequent, right? So I've listed a lot of metrics here, which will help help find out, right, heap characteristics or GC characteristics, right? I think the core problem is this, right? Looking at the GC, you should be able to find out if you are going to trend to an out-of-memory exception, if you are going to see fragmentation, if there are any pauses. So look at the three graphs in the page, right? So here's a good in the first graph, right? You could see that the red line, which is your free space after your garbage collection, gradually coming down. So this is one. When you run out, when you have memory leaks, you will not see immediately. It will slowly come down and eventually just crash, right? And to your right side, right, you have another graph where the red line is nothing but your free, basically your allocation, spaces, right? So this number obviously will be smaller because you're talking purely about allocation failure. But this is a case where you will run into this fragmentation, right? Because what is happening is you're not having contiguous blocks, basically, available for an object to be allocated. And the last one, this one is a nice-looking heap dump or a nice-looking GC, very, very healthy. You have enough, when you have GCs running regularly and heap being freed up. So that's about memory profiling. The last topic, quick 2 minutes, is about thread dumps. It's very, very common to run into a state where a JVM is slow, right? Or you do not know why is it slow, but it is slow, right? It could be because of dead loss, database, network contention, anything. So that's where Java cores help. You take few Java cores in a period of 30 seconds, and you will get a good view of what is causing the issue, right? So typically, right, when a Java core is taken, it will give you information as what are each of the 30 or 40 web container threads doing? Are they waiting? Are they in a running state? Are they waiting on some other thread? Is there a deadlock? all those features, all those information will be, taken through a Java code. So the best practice is, if you run into an issue of Java, JVM being slow, take 2 to 3 thread dumps in 30-second interval, and then compare the thread IDs, right? So it looks something like this. So if you see this graph or this picture, I've loaded a thread dump in ISA. So there are a lot of these web container threads here, right? So I've selected one of them, and it clearly says that all threads are, so I've selected one thread here, and it says that this thread is holding up like, almost 15 threads. So then you know that there is a bottleneck. Then you go and find out what that thread is doing, and then it will tell you that it is holding a lock on some other object, right? So that's how you kind of narrow down, what happens in a thread dump. So I just want to finally summarize one slide on key takeaways, right? Site performance is extremely critical. I would say it's the biggest cross-cutting concern in any e-commerce application. We need to approach performance tuning in a very tiered fashion. Every tier is important, and it's not just your code or design. The third is caching. Don't leverage is probably your single biggest lever to achieve high performance. The fourth is watch out when you customize WCS. Well, out-of-the-box frameworks will offer good performance. If you make terrible, customization decisions, it will actually kind of kill your performance. And then the last is, right, code profiling, heap dumps, thread dumps, and GC logs are really the best way to measure performance and improvements. So, with that, right, I just want to, pause here. We've covered a lot of, topics. Like I said, right, treat this as a 101 because, there are, you can talk about these topics for a long, long time. So with that, I want to just jump to, come to the end of the webinar and see if there are any questions from the group. So, Keshav, do you have any questions? Or do you have collected any questions or any questions?
Yes, Pratap, thanks for the presentation. I have already shared the questions with you. Can you see them in the questions pane?
Yeah, one moment. Just gonna. So the first one is, can you please explain Akamai? So Akamai is a CDN, right? So our content delivery network. So Akamai, in today's world, right, when you have, when you talk about caching, there are a lot of providers like Akamai, even Amazon. They offer content delivery solutions. So what happens is, right, they have a lot of edge servers that are geographically located at various parts in the world, and essentially, when your content is delivered to the end user from the server closest geographically. So if I'm sitting in Chennai, and I could have an Akamai server in Chennai, that is rendering content to me instead of my actual servers, sitting in, say, Boston or California. It's a caching solution. It's AKAMAI. Definitely look more on the web. It's pretty much all websites use CDN, or content delivery network. All of them might not use Akamai, but most of them use content delivery networks. So the next question is, how does domain sharding, how can it be implemented, right? So like I said, right, let's say you have JavaScript, CSS, and images, right, all rendered from one domain. A browser can make only 5 to 6 connections to a domain at one shot. So if you have 20 assets, 20 JavaScripts or CSS to be downloaded, it can if all of them are located in one domain, you will have just 6 calls first made. Once they are downloaded, then the next 6, and then once all of them are downloaded, then the next 6, right? So it's not very efficient. So what people do is the underlying HTTP servers might be the same, but they will expose multiple domains in the internet, like web1.blah.com, web2.blah.com, web3.blah.com. So the browser will think that there are multiple domains to render. It is very you can easily implement them by changing your code to have some kind of logic, right? Where you can kind of establish some kind of domain affinity, right? So what we used to do is we will look at the length of the JavaScript and CSS and do a mod by the number of servers. So if it is mod 1, it will go to that first server. If it is mod 2, it goes to the second server, and likewise. So that's about domain sharding. So the next one is, Websphere Extreme Scale is having a remote call. So is that the impact in performance? That's a very good question. So if you use Dyna-Cache, it's all from your JVM, so there is no remote call. So it's much better in performance. But what we have seen is the remote, the calls from your WAS to Extreme Scale, they're extremely fast. So you would spend really 2 to 3 to 5 milliseconds. Again, 5 milliseconds in the cost, right? So they're very fast, and they're not HTTP calls, right? They're made at a lower layer. So you should not see any impact in performance. They will still be a little slower, considering reading it from your actual JVM, but then your performance will be very negligible. And if you compare that to the benefits you get, it's definitely lopsided. You will get a lot more benefit. So the next question is, do we need to make XMX and XMS values the same? It really depends, right? Typically, I would suggest don't make them same because but if you find through your performance tuning that they can be same, go ahead. But in most of the engagements, they are that I've worked on, your maximum and your smaller value are different. The next question is, how does having data and registry, which changes often affect the performance? So registry is a caching feature in WCS, right? So it is meant to store primarily static data. Like if you have any countries or static text that you have in your database, like what you call typically, right, master data. So that master data is what is actually stored in a registry. There are registry APIs to add, edit, and delete, content, and there's also data to refresh it. So the idea is data in registry after your JVM is started should not change. But if it changes, then you will need to refresh that particular registry. So if you go to Websphere Commerce admin console, there is an easy way to refresh each of the registries, or you could also just use commands to basically refresh them. So in summary, right, you cannot have data that changes in registry, but that's why you have Dyna-Cache, right? So you can have good invalidation techniques in Dyna-Cache, so that so that when data changes, right, the cache is invalidated actually. So the next one is, can I generate the heap dump at will? So you can generate the heap dump at will. I think, but watch out, right? Typically, right, when you generate the heap dump, your JVM will is a huge load on a JVM. So if a JVM is already dying, if you go generate a heap dump, it's like shooting in its head, right? It will just die immediately. So, but if you want to know the memory profile, there is really no other way, right? You can do a kill -8, or you can use WS admin commands. It's a command shell for in WebSphere to generate heap dumps. You can use Jython scripts to also generate heap dumps, but heap dumps are much more expensive and straining on the JVM than a thread dump. So just be careful on that aspect. The next one is data beans, access beans. What's the relevant reason for using less data beans? So access beans is used primarily by your controllers, right? Because you want access control policies reflected, right? On the other hand, data beans are used in your JSPs. So, once your controller does the job, whether to persist in the database or not, it will basically redirect, forward it to a view, right? And the JSP corresponding to that view will again have to, read from the database. That's why you have data beans. Data beans are, you can lazy load. If you're loading a huge order object, you don't need to, do a deep load. You can do a shallow load, just get only the metadata of that order instead of getting all the items, etc. Right? The next one is if you can please define a single tool to manage all exceptions in e-commerce. So I guess you're referring to when you talk about exceptions, you're referring to application exceptions, and so the best way we have actually done it is we've written simple shell scripts or Perl scripts, right? You can write, we have written a Perl script which will just scan through all your 100 JVMs and in each JVM find out what are all the exceptions. That's some nice grouping and kind of render you a report which will say these are your top 50 exceptions and each exception is occurred 150 times or 200 times, right? So that anyone looking at the health of the log will know which are the most offending exceptions. There's no way you can tune all your exceptions, right? Typically systems go live. You look at system out log, it will be flooded with exceptions. It's okay, right? We just have to actually, write some good scripts and find out and start attacking them one by one. So the next one is how to address conflicting needs of security and performance, and what are the strategies to handle. So it's a very good question, right? So we just had a discussion yesterday. So on one of an example where this topic came up, right? So a classic example is right. Let's say you have a page, right? So a lot of us have a login page, right? In any banking site or e-commerce site. These login pages per se doesn't need to be in HTTPS, right? They can be in simple HTTP, but it's given as HTTPS so that the user feels good about it, right? But if you load it in HTTP, your page will be easily 2 to 3 seconds faster than loading it in SSL, because it has to do SSL handshake for each of the assets, right? So this is a good example of how security and performance conflicts, right? Typically, security teams have their way because it's an unknown risk, and no one wants to take any chance with security. But it's a balance, right? The key strategies that I've used is whenever there's a conflict, it needs to be, most of the e-commerce companies have a proper, very mature security team. If you have a performance benefit that will compromise security, you will need to articulate the benefit and situations where it will compromise. But mark my word, right? More often than not, performance, security will have the way. So coming to the last one or last but one, when integrating with multiple third-party services, how important is your server transaction timeout? How negatively it impacts your application performance for the modules which don't have the third-party integration? So there are multiple timeout settings here, right? One is your transaction timeout. So transaction timeout in WAS, if you set it as 1200 milliseconds or 1200 seconds, for example, right? Which is what, like 10 minutes, right? That can be 10 minutes. But so that kind of defines when you create a controller command, it creates a transactional context. When will that time out, right? On the other hand, when you have a third-party service, right, you need to have independent connection and read timeouts for that service. So if you have 10 services, it is good to have 10 different connection timeouts and 10 different read timeouts, so that they don't wait for 1200 seconds before they are being declared as timed out. By the time 1200, 10 minutes is good enough time where all your threads will be, queued, right? So it is very important to set connection and read timeout separately and leave your transaction timeout purely to timeout when your database is tanked, right? So, if you assume a command which doesn't have any third-party service and does purely a database operation, then the transaction timeout will come into play. Let's say you encounter a deadlock in the database and it has to timeout after 10 seconds or sorry 10 minutes. The last thing is, are there any specific things we should keep in mind for ramping up the cache, right? I have observed concerns like conflicts and requires width of data. So, caching is a very, very, we've done like 3 to 4 weeks of pure design workshops on cache before actually identifying before actually implementing them, right? So caching has to be done carefully. For example, right, when you're creating cache, especially that reside in extreme scale or any in-memory grid, you also need to keep making. You also need to make sure that there are if you need replication, for example, let's say your grid cache crashes, right? You don't want the application to fall down. But if you want replication, then there's a duplicate created, right? So for every entry of cache, there's a duplicate, which means that if you have 15 GB of cache, now your memory requirement is 30 GB. So those are some of the things to keep in mind, right? When you talk about caching in particular, ramping up the cache is simply driven by how much heap you have in your extreme scale or in your Dyna-Cache. So or any in-memory grid. Let's say I use an in-memory grid and I have 4 GB heap, and I have it across I have like 15 servers. Now I realize that I'm running very high on heap on a day-to-day basis, like say 80-90%. The only way is to add more servers, right? Or to switch off replication. Both have their pros and cons. What are the ideal log levels one should keep in production? So we've used warning, right? We've typically stuck with warning, and not, but don't enable like performance loggers, etc. in production. Warning should be good enough, and we've seen benefits using that. Does our session bean initialization have cost? I have used significant number of session beans in WCS. I'm assuming since container is managing the lifecycle, it should not be a cost. We are customizing to invoke these as that, right? So I don't think these costs would be significant, right? I think again, right? When you the one good thing I would suggest is use PMI and see, if use some of the counters in PMI. If you suspect some of these will have that cost. I do not think they will have huge costs that will risk your performance. So I think that was the last question that I had. Unless there are any other questions, I think we've come to an end of the session. Are there any other questions, or are we done? Okay. So I think we've come to the end of the session. I want to thank you all again for taking the time out. We've covered a lot of topics, and it's probably a jump start for you to get going, dig deeper. Thanks again, and you have a good rest of the evening. Thank you. Keshav, can I drop off? All right, thank you, folks.
Uh, Thanks Pratap for this really informative webinar. It was really an enlightening session. I would also like to thank all our attendees for joining this webinar. The next webinar on TechGig is happening tomorrow at 3 p.m. The topic is 4 P's: prepare, practice, produce results, and postmortem of software testing learning. The speaker would be Ganesh Sahai, Head Quality Engineering at Aristocrat Technologies. So see you all tomorrow at 3 p.m. Thank you.